Carbon capture, utilisation and storage, or CCUS, is a safe, proven technology in reducing greenhouse gas emissions around the world. It is internationally recognised as a key part of the lowest cost solution to meet global emissions reduction goals. For more than 15 years, CO2CRC has led the Australian effort in progressing carbon capture, storage and monitoring research through laboratory and field demonstrations. This work has resulted in effective solutions being developed for an emerging CCUS industry.
Our major facility, and in fact our major asset, is the Otway National Test Centre, which is located in southwestern Victoria. And over the past 15 years, we've been doing two major phases of research. We've injected around 80,000 tonnes of CO2 into the subsurface. And really over that period, what we've shown is that you can safely store and permanently store CO2. What we now want to do is to conduct what we call Otway Stage 3, try to reduce the cost associated with that longer-term monitoring and verification task, and also to reduce the environmental footprint, which will be not only cost-effective, but will have minimal impact on the surface.
Once CO2 is injected in the subsurface, it has to be monitored. And that monitoring program provides certainty to the operator, to the regulators, and to the community that the CO2 is remaining within the confines of the storage reservoir. Once the monitoring program is started off, it has to be maintained during the entire injection program, not just during injection operations, but also beyond the injection operations, potentially for decades afterwards, until the plume has stabilised.
Among dairy farms in southwest Victoria, the CO2CRC Otway National Research Facility is Australia's first demonstration of the deep geological storage of carbon dioxide. In our previous research project, carbon dioxide was injected 1,500 metres underground at the facility. We showed that CO2 injections into the deep subsurface can be confidently forecasted and validated, and therefore safely and securely stored indefinitely. This was proven with above-ground monitoring using 12-tonne vibra-sized trucks to provide seismic source energy, which reflects off geological features in the subsurface. The reflected energy is received by sensitive geophones buried just below the surface and analysed by geophysicists to identify the presence of gas in the storage reservoir. This can be an expensive and disruptive process, requiring lengthy lead times for consultation and approvals. Acquiring the data and interpreting it is also time-consuming.
So with Stage 3, we'll be moving the monitoring techniques into the subsurface. We'll be looking at emphasising the benefits that come with the imaging techniques used to identify the plume in the subsurface, while really challenging some of the difficulties and the limitations that are associated with conventional seismic imaging.
In our next stage of technology development, we will enhance and validate techniques to instead monitor the CO2 in the subsurface. The seismic signal, generated now by low-profile stationary orbital vibrators, SOVs, can be triggered automatically to generate minimal seismic signal, enough to be received by the highly sensitive fibre optics in the monitoring wells located deep underground. The high-definition signal can be rapidly processed using the latest algorithms and converted to images within days. Pressure tomography uses discrete pressure pulses generated by injecting small volumes of water back into the storage reservoir. This pressure pulse is received by highly accurate monitoring gauges located in the adjacent monitoring wells. The time and strength of the signal is immediately analysed to provide a profile of fluids in the subsurface. The comparison of signals between wells over time allow the gas plume to be triangulated and located, and within hours of the pressure survey being conducted. These new methodologies and technologies provide the capability to observe the CO2 plume on demand, and as monitoring is happening underground, the impact on the surface is minimal. The data is provided quicker, at higher resolution, and at far less cost than a surface seismic survey.
The research at our Otway facility allows us to deeply decarbonize our industries, or we are building the technologies that help us to get there with a higher degree of confidence, at lower cost, and to reach our emission targets much faster.